All right. Hello. Good to see you guys, and hope you are all doing well. Happy Thursday. Here's a quick video to show. We're going to just do a few of these problems together to help you guys out. So let's get started. So there are just a few problems here, all involving simple harmonic motion with masses on the end of a spring. I'm going to try out this new tablet that I have. Let's jump in here. So problem number 1 says a 0.5 kilogram puppet oscillates on the end of a light spring with a constant of 2 newtons per meter, and to find the period. So we have the equation from before, from our notes. We know that the period, the period t is equal to 2 pi times the square root of m divided by k, where m is the mass and k is the spring constant. Pi is, of course, the constant, 3.1415. 2 is 2, and then t is the period. So that's what we're solving for. So now let's look at what things are given to us here. We are given this part of the equation, which says that the spring constant is 2 newtons per meter, and we're also told that the mass of the spring is, the mass is 0.5 kilograms. Oh, that's a little hard to read, but all right, so let's work with that. So we know that mass is equal to 0.5 kilograms. We know that the spring constant K is equal to 2 newtons per meter. And then, so we just plug this into this equation right here. And let's see, so 2t is equal to 2 pi times the square root of m, which is 0.5 kilograms. That's really hard to read. Divided by k, which is 2 newtons per meter. Now, we can plug this into our calculator, but I'll show you a trick here as well. So if we plug this into our calculator, we are going to end up getting 3.14 seconds. Now, I want to show you why that's the case. So 0.5 is the same thing as 1/2, right? So 1/2 divided by 2 is 1/4. The square root of 1/4, the square root of 4 is 2, so the square root of 1/4, so this is really 2 pi times the square root of 1/4. All right, 1/2 divided by 2. Square root of 1/4 is equal to, square root of 4 is 2, so this is 1/2. So this is 2 pi times 1/2. The 2 and the 2 cancel, and so we're just left with pi. And this is equal to 3.14 seconds. Right? The second part, the frequency, they ask us the frequency. So f is equal to 1 divided by t. In this case, so it's 1 divided by 3.1415, ... We'll plug that in our calculator, and I got 0.318. 0.318 seconds. Oh, sorry, not seconds. That should be in hertz. All right, so that's the first problem. Second problem is same thing. In this case, and I won't do this one, but basically the same equation. We're given Anna's mass here, and we're given the spring constant here, and we want to know what's the period of oscillation. 3 is the same problem as well. So if you have any problems with those, just send me an email, and I will help out with those. Let's see. Number 4, let's take a look at this one. Number 4 says a toy bobs up and down over Campbell's crib. I don't know who Campbell is, but part of the problem. So with a period of 1.6 seconds, the toy hangs from the end of a spring whose spring constant is 20 newtons per meter. What is the mass of the toy? So what we're looking for here is the mass, right? And so we're going to have to go back to our equation here. So the equation is, let's see, t is equal to 2 pi times square root of m over k. and I want to rearrange this equation to solve for mass. So this is similar to what we did with the pendulum problems, but instead of L and G, we have M and K. So the first thing I'm going to do is divide both sides by 2 pi. So I get T divided by 2 pi is equal to the square root of M divided by K. Now I have the square root here, so to undo the square root, I have to square both sides. So I'm going to square both sides. So on this side, I'm going to put T divided by 2 pi, square that, is equal to M over K, right? Now I'm going to simplify this side, so T over 2 pi squared is the same thing as T squared divided by 4 pi squared. I want you to notice here that I'm squaring everything that's inside this parentheses, or everything on the left side. So that's the T, the 2, and the pi. So I get T squared over 4, which is 2 squared, over pi squared, is equal to M over K. Okay? And the last thing we're going to do to solve for mass is multiply both sides by K. And so what you end up getting is the mass is equal to T squared divided by 4 pi squared times K. Good? Alright, so now we can plug in the parts of the equation. So we're given, let's see, this is equal to T squared. Our T was 1.6 seconds. We're going to square that. And then we're going to divide this by 4 times 3.1415. Multiply this by K, which is 20 newtons per meter. And we plug this into our calculator. I'm going to do this right now with you guys. So 1.6 squared divided by 4 equals that, divided by 3.1415 gives me that, multiplied by 20 gives me 4.07, right? So 4.07. So this gives me, where's my mouse? 4.07 kilograms. So that's how we solve that problem. The second one, number 5, is asking us to solve for the spring constant. So we're going to have to do the same algebra steps, but instead of solving for M, we're going to solve for K. So here, I'm going to start the same part. So we'll just read the problem. When the mass of 25 grams is attached to a certain spring, it makes 20 complete vibrations in 4 seconds. What is the spring constant of the spring? So the first thing I actually want to do here is it says it makes 20 vibrations in 4 seconds. And so what I know is that the period, T, is equal to the time for one cycle. So the seconds time for one vibration. So what this means is it takes 4 seconds for 20 complete vibrations. And so what that means is if I were to divide this out, I end up getting 4 divided by 20, or 1 divided by 5, which is 0.2 seconds per one vibration. So that is the period. The second thing we'll write down is mass is equal to 25 grams. We have to convert that to kilograms, so divide by 1,000, and that gives me 0.025 kilograms. Alright, so now let's do the algebraic steps. So we're given this equation, T is equal to 2 pi times the square root of M over K. And we're going to do the same thing we did above here. We're going to first divide by 2 pi, so T divided by 2 pi is equal to the square root of M over K. The next thing we did was to undo this square root, so now we're left with t squared, and I'm just going to jump a step here, t squared divided by 4 pi squared is equal to m over k, right? You see I got rid of the square root. And now we're going to have to do a little flip-flop with the algebra here. So I want k to be by itself, but I want k also to be on the top of the equation. So first thing I'm going to do is multiply by k to move it over here. So I end up getting t squared over 4 pi squared times k gives me mass. Now I have k on the top here, that's good, but now I need to move this whole thing over to the right, and so the way I'm going to do that is in steps. First I'm going to multiply by 4 pi squared, and then I'll divide by t squared. So I'm going to multiply by 4 pi squared because it's here on the bottom. So this becomes t squared times k equals mass times 4 pi squared, right? And then the last thing I need to do is to get rid of the t squared is divide both sides by t squared divided by t squared, right? This ends up canceling out, and I end up getting k is equal to mass times 4 pi squared divided by t squared. That's a squared there. Let's clean that up a little bit. Let's see, where am I here? Right here. Divided by t squared. So we can just plug in some numbers here. So the mass is 25 grams, 0.025 kilograms, times pi squared, so 3.14 squared, divided by t squared. In this case, we found out that that was 0.2 seconds squared. And we plug it into our calculator. 0.025 times 3.14 squared gives me this number, divided by 0.2 squared gives me 6.16 is the spring constant. 6.16 newtons per meter is the spring constant. All right, just double check. I did these problems earlier and just want to make sure that I didn't make any mistakes there. So number 5. I feel like I made a mistake there. It's 0.025 divided by 0.2 squared times 4 times 3.1415 squared. I think I forgot to square the pi. Oh, I forgot the 4. That's what I'm missing. I'm missing a 4 here. Ooh, look at that. There's a 4. So this is 4 times this. So this is wrong. The actual answer should be 24.7. 24.7 newtons per meter. And let me just double check the one above. Let's see, number 4. Oh, I got a different answer here as well. I forgot to square the pi, I think, here. So number 4 is also wrong. No, this should be squared. Well, look at that. 1.6 squared divided by 4 divided by 3.14 squared times 20. 1.29, 1.30. Yep. All right, sorry about that. So glad I checked this. So this is wrong too. This should be 1.30 kilograms. So what I forgot to do here was it's 4 pi squared. So if you're still watching and you caught that, well, good for you. So number 6 is the same problem using the same equation, and then number 7 is extra credit, but I'll give you a hint here that you don't actually have to do all the problem, but one way is to solve for k and then use that for this new mass. And I'll post solutions here shortly as well for how to do those. And then on the second page, it's asking you to go to the PhET sim and to play around with those different masses. If you do this, when you do this, I'm just going to tell you the numbers that I came up with. So the period, oh, here, it's right here. So the numbers that I came up with were, so the mass, the 250 gram mass on the light spring, I got a period of about 1.82 seconds. The period I got on the heavy spring was 0.918 seconds, and that was with my own measurements. And then I rearranged the equation to solve for k. This is exactly the same work that we just did for, let's see, for number 5. So all of this algebra should go back in there, number 5. And then when you take your data and you measure it and you graph it, you get some of these measurements. And when I found the slope of those two, oh, the graphs didn't show up. Well, the graphs, so you should have gotten a graph that looked, oh, that's terrible. Let's try that again. Let's see if I can do it with my pen here. So the graph looked like this, and on one of them, you've got a graph that looks like this. Actually, the light spring, I think it should be like this, and then this one. Oh, here, let's label our graphs. This is x, and then the vertical is force. And then this one, we got a graph that went straight down. This one is x, and then this is force. Force. And when you did this, or when I did this, I found that the slope of the light spring, my k value, which was equal to the slope of this, was equal to about 3 newtons per meter. When I did the same thing for the stiff spring, I got the k, or the slope of this graph, to be about 3 times that, or 9.1 newtons per meter. Oh, why is it doing that? Newtons per meter. So those are some answers to help you out. If you're stuck on any of these, let me know. This assignment is due in classroom tomorrow, and that'll wrap up our week here. And then next week we'll be off for spring break. I know it's not a lot of difference between before and then, but there will no longer for next week be any additional assignments for you guys. But if you're still getting caught up, I will be around. We'll all be sheltering in place. So if for whatever reason you haven't finished those assignments yet and need time to get caught up, next week will be that time for you. When we come back after spring break, which is the 13th, we are going to start on a regular schedule here. And we're all still working out the details for what that schedule is going to look like, but stay tuned. So keep an eye out for an email from me and possibly a fun video. So I hope you guys are all doing well, and I will see you all later. Bye.